Welcome to our podcast, Inside Human in Medicine, where we explore groundbreaking discoveries and innovations. I'm Dr. Henri Ford, the Dean and Chief Academic Officer of the University of Miami Leonard M. School of Medicine. We're joined today by Dr. James Galvin, Professor of Neurology and Founding Director of the Comprehensive Center for Brain Health at the Miller School of Medicine. Dr. Galvin, welcome.
Thank you.
I'm so delighted to have you here. You are arguably one of the leading authorities in neurocognitive disorders such as dementia. I know we don't have enough time to delve into your amazing background and to hear about your career and your story, but please give our listeners some of the key highlights from your journey, starting with how you became interested in this disease to become such a preeminent neurologist.
Well, that's a great question. Like many people, I had a journey. When I was 5, I told my mother and father I wanted to be a doctor, and that pretty much stayed the same throughout. I was always interested in the brain. I grew up in a 2-family house. My grandfather lived upstairs, and we lived downstairs, very close to my grandparents. And during my junior year of high school, my grandfather was driving me home from swim practice. I was a little thinner then. And he made the slowest left-hand turn possible. And being a junior, I was just starting to drive. So I remember turning to him and saying, what was that?
What's up?
Right? And he said, I don't know, the car didn't work right or something like that. And didn't give much thought about it because, again, I was 16. And about a month later, he was at work, fell off a ladder. And broke his ribs. Wow. In the emergency room, the ER doctor turned to my grandmother and said, how long has your husband had Parkinson's disease? And she goes, what are you talking about? And she pointed out the tremor. And then over the next couple of years, I actually watched this really vital man that I grew up with and did all sorts of things with slowly become both motor impaired and then eventually cognitively impaired. And by the time that I was in medical school, he was suffering from dementia and could no longer correctly place me in time. So to him, every point after that, I was always still in college applying to medical school. So even after I had finished medical school and finished my residency and was practicing, he still only could place me in the time of college. So
he would ask you, did you get into med school?
Right, okay. Right. So he would ask me the same questions over again. And I got to watch all the symptoms that eventually really changed the way that he was. And eventually he fell down, broke his hip, and passed away. So to me, this has been not just a professional activity, but really been a personal battle to try to improve the outcomes of people living with these diseases.
What an amazing and inspiring story. And here you are now, really one of the leading authorities in the field. So, which brings us to today's topic, the Lewy Body Dementia. But when we hear in the community about dementia, everybody thinks about Alzheimer's disease. So please tell us a bit about the various types of dementia.
So dementia is a general term. It describes a change in memory and thinking functions that interfere with your ability to do your everyday activities. There are many, many different causes of dementia. Alzheimer's is the most common cause of dementia, about 50% of the time. But that means the other 50% of the time, there's some other causes.
Got it.
And the other main causes, one are Lewy body dementia, which we'll talk more about. Vascular dementia due to strokes, and something called frontal temporal degeneration, which affects personality and behavior. So those 4 diseases make up about 99% of cases.
So those are the most common ones. So tell us about Lewy body dementia and why you're interested in it.
Well, beside my personal interest in the disease, Lewy body dementia is the second most common cause of dementia. Affects 1.6 million Americans.
Wow.
So in many cases, it's really the most common disease that people have never heard of.
Wow. And the incidence is increasing?
Well, it increases with age, and it's more common in men, whereas Alzheimer's is more common in women. And we have diagnostic criteria which allow us to make a diagnosis. So people who have Lewy body disease will have a dementia, change in their memory and thinking, Parkinsonism, so slowness in movement, stiffness, balance problems, hallucinations, fluctuations where they kind of turn on and off with their attention, staring spells, blank looks, and something called REM sleep behavior disorder where they act out their dreams.
So now I understand that some famous actors had this problem. And so how do you diagnose it, or is it something that you can easily diagnose? Lewy body dementia.
Well, in the hands of people who really understand the disease, it's possible to make the diagnosis.
Okay.
The criteria are very specific, right? So if you say someone has Lewy body disease, you're likely to be right.
Okay.
But they're not very sensitive. So particularly early cases can be mistaken for something else.
Wow. Like what?
So, for example, if you present predominantly with a memory symptom, you might be diagnosed with Alzheimer's disease.
Got it.
If you present with slowness in movement, you might be diagnosed with Parkinson's disease.
Okay.
But more importantly, if you present with behavioral problems like depression and hallucinations and delusions, false beliefs, you could be diagnosed with a psychiatric disease like schizophrenia.
Wow.
And this could have serious consequences.
Wow.
One, you're the wrong diagnosis, and two, you can be exposed to medicines that are potentially dangerous.
Got it. And I assume the earlier you can make the diagnosis, the earlier perhaps you can get some treatment. Is that true? Is that valid, or is there any treatment?
Well, the earlier you get the diagnosis, the better we are going to be preparing you and your family for the journey ahead, and we can work with you on that journey.
Okay.
Unfortunately, in the United States, there are currently no approved medications to treat Lewy body dementia. So we borrow medicines from other specialties in order to treat the various symptoms.
Okay. So how do you diagnose this? Is there a blood test? Is there something we can say, hey, you come in with those symptoms and then boom, this is it?
Well, the diagnosis right now is purely a clinical diagnosis based on doing all of the examination, the evaluation, and seeing if people have the criteria. It's a major focus of our research to try to develop new laboratory tests. In recent years, there is a skin biopsy test that can be done, and we can look for signs of Lewy bodies in spinal fluid.
Okay. So I gather that early diagnosis then is more important for preparing the family as opposed to just any actual intervention to improve the outcome.
Well, we can treat all the symptoms, and that makes a huge difference in people's lives.
So that's important,
right? But we can't reverse the disease because we're still not there yet.
Got it. Which brings us to today's topic. So you and your colleagues just received a $29 million grant from the National Institute of Health to conduct research in this area. So I understand it's a phase 2 clinical trial to try a drug known as CT1812.
Yes.
So tell us about this clinical trial in general, and how does this CT1812 work, and what do you expect to get out of that?
So this is a phase 2 study. So
which means what?
Predominantly safety and tolerability, but also collecting measures that look and see if the drug works.
Okay.
So CT18.
So safety and efficacy. That's what you want.
Yes.
Got it.
So CT1812 is a small molecule. It works against a receptor called the sigma-2 receptor. And what we believe to be doing is it blocks the toxic effects of the proteins that make Lewy bodies. This is alpha-synuclein.
I see.
And
so tell me about that. That sounds like a pretty fancy name.
Yeah. So the sigma-2 receptor, we think, is sort of the linkage to where the toxic molecule can bind to a cell and then cause...
What makes this toxic molecule?
So your body makes a protein called alpha-synuclein. Alpha-synuclein normally is a synaptic protein, so it probably helps with cell communication.
Okay.
But for reasons that are not entirely known, some people overproduce it, and then it starts to take on an abnormal form where it can start to clump together and form eventually a Lewy body, which is the pathology in Lewy body dementia.
Got it. So, and this clumping of the protein interferes with the signaling between cells, so they can't talk to each other anymore?
It interferes with the signal to cell, and it can be transmitted from cell to cell. So one cell that's got an abnormal clump of protein can pass that clump onto another cell, and that cell starts to degenerate, and so it becomes a cascade. So we believe that this molecule can block that aggregation.
So that's how it affects brain function, leading to dementia, we think?
We believe so.
Okay.
And so that's what we're going to be testing in this trial.
And how does CT1812 stop all of that?
Again, it seems to bind to the sigma-2 receptor, which is a binding site for the abnormal protein, and block it. So if you look at cells that are infected with alpha-synuclein, and you treat them with 1812, you remove all those aggregates, and so the cell then looks healthier. Yeah. So that's what we're going to be testing in living people.
Fascinating, fascinating. So why is this so important to the NIH? You put $29 million into this project.
Well, there are no treatments currently available to treat Lewy body dementia, and so this is the largest grant given by NIH to date to study this disease. So we're very excited about that.
Amazing. And of course, it comes to you and your colleagues.
Yes.
A testament to your role and your position internationally in this disease. So fantastic. And we're so happy you're here at the University of Miami.
I'm happy to be here.
I just want to add that as your dean. So how many patients do you plan to enroll in this phase 2 clinical trial?
So we're going to be looking for 120 people across about 25 sites.
Okay.
That are using a network of research centers of excellence in Lewy body disease, of which I direct the center that's at the University of Miami. And so this way we're sure that we're dealing with clinical experts, so we get the correct cases, and we want to bring people into the study.
Okay. And have you studied enrollment on it?
So we have our first person in, which is always the key feature of a study, is to get that first person in.
Okay.
So first person's enrolled, and the rest of the sites are slowly being activated as they go through all the regulatory documentation.
Oh, fantastic. Over how long do you anticipate you will be enrolling patients, or is there a timeline?
Yeah. So it's a 6-month study. So the actual active part of the study is 6 months.
Got it.
So we anticipate getting the other sites all activated and start to enroll.
Okay.
Our plan is to enroll over a 1.5-year period.
Okay.
And so that the last person in would then be coming out 6 months later. And then this is a phase 2 study, but it also is designed to potentially be a registration study.
Okay.
So if we have a positive signal, we could apply for FDA fast tracking or breakthrough, so that we only need one more study for treatment.
Okay. Well, that's really, really good. So the one more question. Assuming it does work, okay. So what would be the next step?
So if it works, which we hope it does, the first step would be to try to establish a long-term extension study, so that people in the study currently can continue on the medication.
Okay.
And then to begin designing and enrolling for a phase 3 study, which would be a much larger study focused on efficacy itself.
Okay.
We still collect safety measures, but the primary goal of a phase 3 study is how the drug works.
Got it. So how often are you administering the drug in this phase 2 trial?
So it's a daily dose of the medication. It's an oral medication.
One dose daily.
One dose daily. And this particular study has 3 arms. So a placebo arm and then 2 different doses. So we want to test placebo versus treatment, but then within the treatment, try to establish the most effective and tolerated dose.
How hard do you think it's going to be to enroll patients, since not too many people can make the diagnosis?
Well, again, one of the keys of really using the Research Center of Excellence network is that we already have hundreds of patients that we've evaluated. And so just at University of Miami, we have a wait list of several dozen people who have expressed interest. We can't do anything with them until we finish all our regulatory paperwork, but that expressed interest. And then we can then screen those people for eligibility and hopefully quickly get them into the study. Okay,
so for people who are not part of these centers of excellence, who hear this podcast, how would they be able to say, I have my family member who maybe have this dementia, this form of dementia, maybe Lewy body dementia. How would they enroll in one of these
Right. So there are several different ways you could find out. So first, the trial is registered at clinicaltrials.gov, which is the national registry of all clinical studies, and they'll have contact information.
Very important.
They can contact the Lewy Body Dementia Association, which is the main disease association for Lewy body dementia, or they can contact me directly and I can put them in touch with the nearest site.
Fantastic. Well, this brings us to the next question. So, assuming we continue to make progress, what do you think are the remaining challenges that you in your career must address to get a more, comprehensive handle on this problem?
Well, I think one of the things we really want to do is, one, understand how the disease presents in different groups of individuals.
Got it.
So a lot of our studies are focusing on looking at multicultural samples. So, for example, the way we diagnose it in a white individual is the same presentation true in someone who's African American or Caribbean or Hispanic or Asian or indigenous populations. So that's a major part of what we do.
Fantastic, because I was going to ask you, is there genetic predisposition, or are there certain types of patterns that we can say are more common to one form of dementia versus another? I know, for instance, Alzheimer's is linked to this APOE4 gene and so forth, that some of our scientists here at the University of Miami and the Hussman Institute for Human Genetics I've been working on, and I'm wondering if you collaborate with them, if this, just tell me a little bit about the genetic predisposition, if any.
Right.
To Lewy body.
So all science is really team science, and so it takes a team to do this, and so we collaborate extensively with Dr. Vance and her group on genetics. But it's, it gets to an interesting question. So most diseases are sporadic, which means they occur randomly in the population. So very few are caused by a genetic mutation, but there are genes that put people at higher risk. This APOE gene, for example, being one of the most prominent ones. What's really interesting, though, it's very strong risk factor in European whites. It's a weaker risk factor in African Americans and Hispanics, and it does not seem to be a risk factor in indigenous populations. So, for example, it seems to have no effect in disease risk for American Indians, Alaska Natives, Native Hawaiians, Pacific Islanders. So while there are genes that put people at risk, there might be very, very different genetic predispositions based on your racial, ethnic, cultural backgrounds. And so if we don't study this, we really won't ever understand disease.
So what are you doing now to study these types of genetic variability?
So several things. So I am one of the principal investigators on a large program project, the largest program project given by NIA to study indigenous populations. It's called Natives Engaged in Alzheimer Research. So it's a multi-site study, and we're looking at genetic and disease risk factors in American Indians, in Alaska Natives, and Native Hawaiian populations. And then we're waiting for the notice of award, but we were told we got it, of a large $14 million grant to do the first Alzheimer's study in American Samoa.
Yeah, I mean, so, last time I counted, there were at least 6. You had at least 6 NIH grants or multi-center grants, and then probably over the weekend, probably added some more. So tell us about the breadth of research that you're doing with all these various grants, and one that I didn't even hear about, but I'm excited about to hear about $14 million to add to the 29.
Yeah, so this is very exciting. So been very fortunate in the recent years to really be able to successfully be funded to study things that I think are really important. So one is how these diseases present in different populations. And then 2 is how do we best diagnose this? So helping to develop biomarkers. So our lab is very interested in looking at novel plasma blood-based biomarkers. Because ultimately, if we want to be able to provide diagnoses to the general population, we can't be doing $1 million tests, right? We have to be able to translate those $1 million tests into something that could be done in clinical practice. And so our lab is focusing what we can do internally in our own lab, and then collaborations with numerous corporate and industry partners to see if we can develop and validate these novel blood-based biomarkers.
That's amazing. So you're really approaching it in a systematic manner. Diagnosis, also cure.
Yes.
So reflecting back on the journey, let's say my family, I have someone who's got dementia. Is there hope for that person?
There's incredible hope. So first, if we establish a diagnosis, then we can help the person immediately, right? We can help them.
And when you say help immediately, what do you mean by that?
We can help them medically, right? So we can give them medicines to help treat the symptoms that they're experiencing. 2, we can help the family understand the journey and prepare them for the changes that may occur. We can do advanced care planning. We can offer non-medicine approaches, so looking at modifying diet, exercise, cognitive and social engagement. And we can help people enroll in clinical trials and other avenues of clinical research. So there are really many, many things that we can do for someone. What I like to say is we can do something for everyone, regardless of where they are in the disease. But it's never too late. It's never too early, but it's better to be too early than be too late. So the sooner we can see someone, the more we can do for them.
I'm sure that your grandfather would be very proud.
I hope so. I believe he would be. I think wherever he is now looking down, I think he would say I did a good job.
It's remarkable. It's remarkable. And it shows how your upbringing and your exposure to this vexing problem has led you to really become a pioneer and a trailblazer to hopefully find a cure for it. And I thank you for the work that you're doing.
Thank you.
What are the unmet challenges, and what would you like our audience to know?
Well, I think one of the key things is if you have an opportunity to participate in research, there really is no other way that medical advancements can be made. And we're looking for people to participate in research, not just people who are affected by the disease, but people who are interested in finding about brain health. And that's why we call our center the Comprehensive Center for Brain Health rather than a memory disorder center, because we're really understanding on what's healthy brain aging and what are the signs that are telling us who might be at risk. So it's really a focus on what makes us resilient, what makes us be able to resist disease, and what puts us at a higher risk for disease. And are those things modifiable? Can we change them?
So tell us a little bit about the stigma associated with dementia, and how should families cope, and drawing on even from your own experience.
Well, the term dementia has a lot of negative connotations associated with it. In Spanish, dementia would translate to being crazy, which of course is not what we're talking about. So there's a lot of stigma associated with the word. And so we tried to then, instead of using a general term, we try to give it a specific disease entity. So Alzheimer's disease or vascular, cognitive impairment, so that we can take away some of the stigma and explain to people and their families what they're experiencing, that we understand what they're experiencing. We can educate them about the disease and prepare them to take this journey with us going forward. But it requires raising awareness of the disease in the community, and providing knowledge and engagement to communities so they can better understand how this disease may be affecting them, and working on education and exposure, which will remove stigma.
Great. Anything else you want to add? Because obviously, when it comes to neurocognitive disorders, nobody knows it better than you.
Well, I think, I've been just impressed in the 3 years I've been at the University of Miami at the tremendous scientific community to collaborate with. That's what attracted me to come here. So yes, I'm successful in research, but I'm successful because I'm at a place that's successful. So I want to thank you for leadership, because this is the place where we can start to address these really important medical questions.
Dr. Galvin, thank you so very much for being a part of our faculty, and thank you for your brilliant work trying to solve this really vexing problem, Lewy body dementia.
Thank you.
Great. As the U.S. population continues to age, we sense that we know, based on the discussion we just had, that Lewy body dementia is likely to be a growing problem. We are fortunate that Dr. Galvin is here trying to find real solutions, and we believe that this new phase 2 clinical trial brings hope to all individuals suffering from Lewy body dementia. Once again, we want to thank our eminent scientists for being part of this podcast today, and to all of our listeners, thank you for tuning in to U Miami Medicine. Until next time, I'm Henri Ford, Dean and Chief Academic Officer of the University of Miami Leonard and School of Medicine. Thank you.